Hello, and welcome to a little video about solving for missing logarithmic values. All right, so first, let's take a look at two problems that are in logarithmic form that we have been able to solve already. Now, this first one, log base 7 of 343, you can input that into a calculator to find x, or if you're doing it by hand, we can rewrite it as exponential. And you say, well, 7 to what power gives me 343, and I happen to know 7 cubed is 343. Again, you still can input log base 7 of 343 into a calculator. I'm going to attach a link to a great logarithm calculator in this video, just in case you'd need it. All right, same thing goes for this one. Log base 3 of 729. One method, enter it into a calculator. Other method, rewrite this in exponential form. And you say, okay, 3 to what power gives me 729? I happen to know that 3 to the power of 6 gives me 729. Again, you can do it by hand like I did, or you can do it with a calculator. Let's take a look if the missing value of x is in a different spot. For example, log base x of 81 equals 2. Now that you cannot enter into the calculator that I have provided for you. This one we have to rewrite in exponential form. So let's do it. The base of my exponent is going to be x. It's the same as my logarithm. And then we follow that clockwise rotation. The 81 will go on this side of the equal sign. And the 2 goes with the base. And now we have an equation that we know how to solve. Well, how do we get rid of squares? We square root. So we will square root both sides. Notice that in the instructions, I have solved for a positive value of x, because when we square root, we do get a positive and a negative. In this case, we stick with a positive, x equals 9. Now there is a reason we're staying with positive, and that is because logarithmic bases, like x happens to be, must be positive numbers. Okay, let's continue. Log base x of 512 equals 9. Again, we cannot enter this into a calculator. So, let's rewrite this as an exponent. X to the power of 9 equals 512. Again, the base of my logarithm is the same as the base of my exponent. Okay, and then I followed that clockwise rotation. 512 went on that side of the equal sign, and the 9 went with the base. Now there's two ways of doing this. You can take the 9th root of 512. But I'm assuming that that might be a little hard to enter into a calculator. You might not know how to do it. Or into Google. The best way, I think, to get rid of an exponent that is larger than, well, 3, I guess, because that's the largest I think most calculators would offer, maybe even just a square, is you raise each side to the power of its reciprocal, so 1/9. This you can enter in your calculator. Now, when entering into your calculator, make sure to enter it like this. 512, the little caret thing, and put 1 divided by 9 in parentheses. When I raise 9 to the 1/9, they cancel each other out. All right, let's input that into our calculators. Oh, not a nice number. 2.003. That's what I got. I hope you do too. Okay, let's try two more. This time, our x is missing inside of the logarithm. What do you think we're going to have to do? That's right, rewrite it in exponential form. Let's do it. We have 9 to the power of 2 equals x. Well, that's easy. 81. Okay, all right, let's try this one. 3 to the power of 2 equals x. Winning here, very easy. 3 squared equals 9. 9 equals x. All right. I hope this was helpful. I think the hardest part, as usual, is remembering how to write those logarithms into, rewrite those logarithms into exponential form. Okay. Have a wonderful, whatever time of day it is for you. If you have any questions, make sure to ask me or your teachers. Bye.